My name is Jennifer Halen. I've been the engineering manager here at Biomerics for about 2 years. I've been with Biomerics in total for about 3. I'm currently working out of Fairfield, which is close to San Francisco Bay Area in California. IMP is interventional medical plastics, and of the many ways that you may interact in medicine, be it surgery or cosmetic procedures, there are plastics in everything we do. If a patient is interacting with the plastic, that they be of a certain quality. So if you look at the very large machines like the MRIs and the CAT scans and the X-ray machines, we are doing the outer skins of those equipment. In med devices, especially, quality is important. The structural integrity as well as the composition of the material has to be there. But also the cosmetic. There are multi-million-dollar pieces of machine, and they have certain expectations on how that equipment is going to look. So a lot of what we do here in Fairfield especially is to make sure that those outer skins represent the brand. Fairfield is unique in some ways in that the 3 different value streams that we do here, the thermoforming, the liquid resin casting, and the 3D printing, actually can come together to complete the package for the customer. So if you look at thermoforming as being the large, bulky outer casework of a large piece of equipment like, a biopsy machine, then liquid resin casting can provide the outer skins for the smaller parts, for the handles, for the articulating arms. And then 3D printing can bring that together with the connectors, the buttons, and some of the speakers. So we do have customers here that we can provide all of the different components for a given cart or, piece of equipment. So in some ways, Fairfield is its own vertical integration. Thermoforming is a technology of using sheet plastic, heating it up till it starts to soften, and then applying pressure on one side and vacuum on the other side to press that sheet into an aluminum mold. Once the plastic is in that final shape, it's cooled and then released from the mold. And it goes through other trimming operations to put it into its final shape. We just purchased a new Mac thermoformer. It is the latest and greatest at thermoforming. It really steps up our game with better temperature control and pressure and vacuum control. Liquid resin casting involves a 2-part polyurethane resin. The resins come together and mix together into a silicone mold that has been formed over a pattern. We call these a cope and drag pattern. One forms the outside of the part, one forms the inside of the part, and together that cavity forms the part. And so the liquid resin is injected into that space in between the 2 silicone halves. It's allowed to cure under pressure, then cooled, and you demold the silicone liner around it and you have a part. What's interesting about the way that we do liquid resin casting is we can actually co-cast the inserts or any kind of bracketing that we want over the plastic. So it's in mold casting as well. We have taken what we've learned with our standard chambers and have incorporated 8 of those into a single unit, which has full pneumatic controls, temperature controls, and timing. So you can put a recipe and hit a button and start, and the operators know when it's finished. And so that has really streamlined the liquid resin casting process. We've cut the load time from 30 minutes to about 16. 3D resin printing at Fairfield is what we call DLS, it's digital light synthesis. The liquid resin is pulled away from the platform as the UV light basically solidifies the part onto the platform. So it's much faster and much more accurate than the filament printing. These are types of parts that usually go inside the surgical unit or the medical equipment and hold cables and speakers and our general attachment. I also want to mention the 5-axis and our CNC, which 5-axis isn't a new technology, but it's new to us. Most of our CNCs are 3-axis. By using 5-axis technology, now we can take many operations that we would normally do in a 3-axis and bring that down into one. And then very complex geometries that we would normally have to do by hand can now be done in the 5-axis machine. So again, this new technology, this automation is really driving down our labor costs and our, improving our throughput, and the quality of the part is much better as well, much more consistent. It takes an operation from, a 3-hour operation down to an hour. When a customer approaches us and says, we have this idea, they've come with a general idea, back of the envelope type of idea, and they want to make this into being, they'll approach us and say, how can we do this? And we take a look at the features of that product. Do we have undercuts? Do we have different components that need to move together? And this mostly the size of the part, and what are some of the requirements? Does it need to be fire rated? Does it need to be an elastomer? Does it rigid? So we'll look at the materials that they would like to use. We develop a strategy to build that part using the various operations we have here. In some cases, we work with them to redesign the part to make it more designed for manufacturability, right? So you want to make sure that you can consistently make that product over some time. The features that we can't do here, we'll reach out to our partners throughout Biomerics and see, where we can piece it together. There are almost no surgical units or, modern medical equipment that don't need a little of everything. 100% of our customers would benefit from the vertical integration that Biomerics offers.